Let's look at the acceleration of an object on a velocity time graph with an acceleration of 2 meters per second every second. Now we hit the button and there's an object accelerating. You can see that its velocity is increasing by 2 meters per second every second. The line is a straight line, which means that it's a uniform line, which means that the acceleration is constant. Now that acceleration of 2 meters per second every second is displayed well on that graph. But say we wanted to find the acceleration of an object from its velocity time graph. Well, we rely on this equation here. The acceleration, as we know, is equal to the change in velocity over the change in time. Now when we're dealing with graphs, it's better to write the acceleration equation in this form here. Acceleration is going to equal to the change in velocity, and that little symbol that looks like a triangle is called delta. It's from the Greek alphabet, and delta stands for change in. So we can rewrite the acceleration as change in velocity divided by the change in time, delta v divided by delta t. And this equation is much more suitable for working from a velocity time graph. Now we know that's the velocity time graph of an object, and it has an acceleration of 2 meters per second every second. So let's work it out from the graph and see if that agrees. Now we do it as follows. We can pick a spot on the graph or a dot on the graph anywhere. We'll choose this one, and we can go across 1 second, 2 seconds, 3 seconds. We'll go along 4 seconds. That takes us from 1 to 5. So I know that in there the delta t, the change in the time, is going to be equal to 4 seconds. 1, 2, 3, 4. So it's going to be 4 seconds. Now I just go up to the graph and I go from 2 to 4 to 6 to 8 to 10, and that's me found my change in the velocity. So the change in velocity is going to go from 2 to 10. So delta v, the change in velocity, is going to equal to 8 meters per second. So you can see that we're really working out the gradient of that velocity time graph, and that's a big point. The gradient of a velocity time graph is really this acceleration. So we can find acceleration from a velocity time graph. So we'll plug the numbers into our new formula, written in a different way. So acceleration equals delta v, which is 8 meters per second, divided by the delta t, which is 4 seconds. So my acceleration is going to be 2 meters per second every second, and I write it that way. And that concurs exactly with what we have in the button. Now let's look at an acceleration of 4 meters per second every second. And you see the graph has got a line which is much steeper. But once again, we can work out the acceleration from that velocity time graph using our modified formula. Acceleration is going to equal to the change in the velocity divided by the change in time. What we're doing is working out the gradient of that graph. So I can choose anywhere on that graph, and say we'll choose the 1 second mark here, and go along to any time we want to stop, as long as it's under the graph. So that's going to be delta t of equal to 2 seconds. So delta t is going to equal to 2 seconds, because we're going from 1 to 3. So the change in time is 2 seconds. Then I go up to the graph, meet it, to work out my delta v. So all the way up to here. So I'm stopping at 12. I started at 4. So my delta v in this case is going to be equal to 12, take away 4, is going to give us 8 meters per second. So we use the equation. Acceleration is the change in velocity, which is 8 meters per second. That's the change in velocity, divided by the change in time it took place, which is 2 seconds, and therefore the acceleration is going to be equal to 4 meters per second every second. And that concurs once again with our button of known acceleration, 4 meters per second every second. Here's a velocity time graph of an object, this time where the velocity of the object has been reduced. The object is decelerating. It starts off at 0 seconds with a velocity of 12 meters per second, and then 6 seconds later it's got a velocity of 0 meters per second. It's come to a stop. Now that's an example of deceleration, and on a velocity time graph, a deceleration has a negative slope. That is going from left to right, the slope is going downwards. So that should give us a gradient which is a negative number, which indicates that the velocity has been reduced. So acceleration, as we know, is equal to the change in velocity of the change in time. And we use our equation associated with graphs. Acceleration is going to be the change in the velocity divided by the change in the time. Delta V over delta T. So how do we work out the gradient of that velocity time graph? Well, we just start any position we want. We'll maybe start at the 12 this time and go along 1 second, 2, 3, 4, 5, and we'll go right along to the end, 6 seconds. So I can say that the delta T for that is going to be equal to 6 seconds. Delta T is going to be equal to 6 seconds. Now all I've got to do now is work out the change in the velocity. So we start here, and remember that's a velocity of 12 meters per second, and this time the change in velocity is downwards, which means our change in velocity is going to be negative. So in this case we're going to have delta V is going to be negative. So delta V is going to be equal to, you're going from 12 down to 0, down the way 12 meters per second, so it's going to be minus 12 meters per second. So if I put those numbers into the formula, acceleration, delta V this time is minus 12 because it's going down the way, minus 12 meters per second. We're reducing the velocity by 12 meters per second, and the time, the change in time for that to happen was 6 seconds. So therefore acceleration is going to be equal to minus 2 meters per second every second. Now that's going to give us a negative gradient, and that's what's happening because the velocity has been reduced by 2 meters per second every second. And you can check that from the graph. If we start here and go 1 second, you can see we've come down by 2 meters per second to 10. Go along another 1 second and we're down another 2 to 8. So you can see it's like staircases going down the way. So minus 2 meters per second every second is telling us that the velocity, the slope of the velocity time graph is actually a negative slope. It means it's going down the way from left to right. So start here and we go along by 1 second and we're going to go down 2. And that's what that means. It means that the acceleration of that object is minus 2 meters per second every second.